Welcome, this is Professor Ridge. Today's lesson 1.4, Polynomials. And let's get started with the first learning objective. Identify the degree and leading coefficients of polynomials. Let's start with the definition of a polynomial. A polynomial is an expression that can be written in the form a sub n x to the n plus ... plus a sub 2 x squared plus a sub 1 x plus a sub 0. I'll give you an example. So looking at this polynomial, 3x to the fourth plus 5x to the third minus 7x squared minus 2x plus 3. Okay, so each real number a sub I, so going back to this definition, the way that you look at this is this is what we call a polynomial in descending order. And we're going to learn some of these terms here. The degree is basically the power of the variable. So in my example here, x is the variable, and we have what we call terms. Terms are separated by plus or minus signs. Technically, remember, a minus is the same thing as adding a negative. So I could have wrote this polynomial as 3x fourth plus 5x cubed plus a negative 7x squared plus negative 2x plus 3. Okay, so terms are separated by addition signs. And then you can kind of, if you simplify it, right, plus and negative is the same thing as minus. So you can say add or subtract. But the terms, you want to think of it in pluses because you want to take this minus with the 7. So this term would be negative 7x squared. Okay, so each of these expressions would be terms of the polynomial. So each product a sub I, so this is what we call a coefficient. So in this case, 3 is the coefficient. For this term, 5 is the coefficient. This term, negative 7 is the coefficient. This one would be negative 2. And then this one would be 3. Okay? So the last term, if it doesn't have a variable, we just call that the constant or the constant term. So 3 would be the constant of this polynomial. The highest power of the variable that occurs in the polynomial is called the degree. So this is what we call descending order when you put the highest term first and then you descend. So this is the fourth degree term, third degree, second degree, first degree constant, or degree 0. So the highest degree term is the degree of the polynomial, and then the leading term is the term with the highest power. So if it's written in descending order, that's where the leading, it would be the first one. You'd be leading. If I didn't write this in order, the 3x to the fourth will still be the leading term because it's the term with the highest power. And the coefficient will be called the leading coefficient. So the leading coefficient would be 3. All right, let's look at example 1. Identify the degree and leading coefficient of a polynomial. For the following polynomials, identify the degree, the leading term, and the leading coefficient. So recall from the definition we just went over, the highest power of the variable that occurs in the polynomial is called the degree of the polynomial. So we're going to do that first. So looking at A, the highest degree term would be the negative 4x to the third. So this is our leading term, even though what I was saying earlier, it's not written in descending order. So that's typically where we get the word leading term. So if I were to write this in descending order, it would be negative 4x cubed plus the 2x squared plus the 3. So the leading term will be, well, first let's talk about the degree. The degree is equal to that highest power, 3, is equal to 3. The leading term would be the highest degree term. So it's the whole term, 4x cubed, and then the leading coefficient is just the number part of that term or expression. So it'd be just the negative 4. Okay, so B, same thing here. So okay, this one's in descending order. So 5t to the 5th minus 2t cubed plus 7t. And remember, with the minus, you want to think of it as this way, plus a negative 2. Okay, so this term is negative 2t cubed. That's where some people get confused with polynomials. You know, you think of the minus sign as a negative. So it's plus a negative 2. All right, so having said that, the degree, this is going to be our leading term, and this is the highest power, right? So this is going to be our degree. So degree equals 5. Oops. Degree equals 5. Leading term is the whole expression, 5t to the 5th, and then the leading coefficient, I'm just going to put that, leading coefficient is the number part of that expression, okay, 5. And then for C, let's see, this is not in descending order, so it'd be negative p to the 3rd plus 6p plus negative 2. So this is our leading term. So the degree would be the power, which is 3. The leading term, let's write LT, is negative p to the 3rd, and then the leading coefficient would be, now if you don't see a number, remember you should know this rule about multiplication. It's the identity property, right? So negative p is equal to, well, you can put a 1 there. So this is property of negative 1. Actually, this is equal to negative 1 times p. So negative 1 would be the leading coefficient. All right, on to the next learning objective, add and subtract polynomials. Adding and subtracting polynomials. So how to, the book suggests your first step is to combine like terms and then simplify and write in standard form. Okay, so standard form is that descending order that I mentioned before. Find the sum. 12, so we got two polynomials we're adding. 12x squared plus 9x minus 21 plus 4x cubed plus 8x squared minus 5x plus 20. So since each term we're adding, remember we're thinking this is plus a negative. So technically what we could do is addition is commutative and associative. So if I'm thinking of it, typically we don't write this, but remember what I said before is we want to think of this minus as plus a negative 21. And since it's associative and commutative, we can drop the parentheses. And then we got 4x cubed plus 8x squared plus negative 5x plus 20. And typically you wouldn't rewrite this. Just in your head, you're thinking negative 21. Now, we can rearrange the order and put it in descending order. So 4x cubed plus 12x squared plus 8x squared plus 9x, so the 9x, and then plus the negative 5x, and then the constants. Let's see, we got the negative 21. And again, we wouldn't write this. this is the kind of the way we would do it in our head. So since addition is commutative, it has the commutative property and it has the associative property, I can drop these parentheses and rearrange the order. That's the rearranging is the commutative part. And now I'm going to do what we call combine like terms. Like terms are terms that have the exact same variable part to the same power. So this is x squared, and we can basically, to combine like terms, we're using the distributive property. We're going to factor out the x squared, and then we're just going to add the numbers. And again, we don't typically write this down, we just think it in our head. 12 plus 8 is 20, and then 20 times x squared is 20x squared. So we can rewrite this, and we call that process combining like terms. So we can combine these like terms, and that would be 20x squared. And then the same thing for these. These are like terms. So we do the similar process. We'd factor out the x, and then it'd be 9 plus negative 5, which is positive 4x. And then these are like terms, just numbers. So negative 21 plus 20 would be negative 1. And we're not going to write plus negative 1, we're just going to write minus 1, because that's easier. And then that would be my final answer there. Now to subtract polynomials, we're going to take care of the subtraction by thinking of it this way. So if we think of subtraction as adding the opposite, right? If for real numbers. And remember what I said earlier is the opposite. You can also think of the opposite can be thought of as negative 1 times b. The opposite of b is negative 1 times b. So a way that I can think of this is I can think of this as negative 1. So plus negative 1 times this polynomial. So we call that, we're going to distribute that negative 1, so on. Okay, so we're going to rewrite this polynomial as 7x to the 4th minus x squared plus 6x plus 1, and we're going to distribute this negative 1, and we get negative 5x cubed. Now negative 1 times negative 2 would be positive 2x squared. Another way you can think of it is you're just going to change all these signs. That's another way you can think of opposite. So either way, either distributing the negative 1 or changing all the signs. It works the same. In the end, you get the same result. So negative 1 times positive 3 is negative 3x. And then negative 1 times positive 2 is negative 2. So again, remember in our head, we're thinking this is plus a negative 5x cubed. Okay? So now we're going to put it in descending order. So 7x to the 4th, and we're going to combine our like terms. So we got x cubes, and there's no other one, so nothing to combine. Now we're going to do x squares. So I have minus 1x squared plus 2x squared. So minus 1 plus 2, minus 1 plus 2, that's equal to positive 1, sorry, because you're going to subtract and keep the sign a little larger. So it'll be plus 1 x squared. We don't need to write the 1 since we have the x squared. 1 times x squared is just x squared. Okay, now on to x's. So again, descending order. 4, 3, 2. Now we're going to do x to the 1st. So we got the plus 6 and minus 3. Plus 6 minus 3 would be positive 3. And then now the constants. So we got the plus 1 and the minus 2. And so 2 minus 1 would be 1. And then take the sign of the larger. So it'll be minus 1. And that will be our final answer for that one. Okay, on to the next learning objective, multiplying polynomials. Multiplying polynomials using the distributive property. So given the multiplication of two polynomials, use the distributive property to simplify the expression. So basically what you're going to do is you're going to take each term, multiply each term of the first polynomial by each term of the second polynomial. Then you're going to combine your like terms and simplify. So the way I like to think of it is, here I'm multiplying two polynomials. The first one has two terms, which is what we call a binomial. This one has three terms, which we call a trinomial. So if you do two terms with three terms, you're going to end up with, before simplifying, you're going to end up with 6 terms. Okay, so 2 times 3 is 6. And the idea then is you're going to take this first term and you're going to distribute it. You're going to multiply it with each term. Okay, so 2x, oh, erase that, it's kind of messy. So we're going to do the 2x and distribute it. So we get 2x. So normally you don't write this, you just work it out and write down the answer. And then we're going to distribute the 2x with all three terms. So 2x times 3x squared, 2x times negative x. So remember, you got to think this is plus a negative 1x. I won't write the 1. And then 2x times the 4. Now, so the first one's done. We distributed it. Now you're going to go to the next term and distribute it. So we're going to do 1 times 3x squared plus 1 times negative 1x plus 1 times 4. And again, you wouldn't write the step down. Just in your head, do it as you go, figure out the answer and write it down. So typically I don't write this step down. You can if you want. It's not necessary. So 2x. Now when you're multiplying, when we call one term, it's called a monomial. So if we do a monomial times a monomial, the way you do that is it's just all multiplication. Multiplication is commutative and associative. Oops, I messed up there. 2x. So 2x means 2 times x. 3x squared means 3 times x squared. So this is all multiplication, so I can switch the order around. And then I'm going to do my associative property. 2 times 3 is 6, so I do the numbers, 6. And then I do the variables, x times x squared. Well, I can use exponent rules, and that'll be, if you're multiplying the same base, you add the exponents. So this would be 6x cubed. So that first term is 6x cubed. Oh, back to my first thing I said, if I'm doing two terms with three terms, you see we have 6 terms here. 1, 2, 3, 4, 5, 6. Before I simplify. Okay, so now the next term, we're going to do the numbers. 2 times negative 1, which is negative 2. X times x, remember we're doing the exponent rule, 1 plus 1 is 2. And then 2x times 4, we do the numbers. 2 times 4 is 8. And then the letters times x. And then the next term, 1 times 3 is 3. And then the x squared. 1 times negative 1 is negative 1 times the x. And then 1 times 4 is just 4. And then we're going to combine like terms. So do descending order. So the highest degree is 3. 6x cubed. Plus, now we do x squared. We got minus 2 and positive 3. So that's positive 1. I'm not going to write the 1. X squared. And then x's. We got plus 8 and minus 1. So that's plus 7x. And then constants is just the 4. So my final answer is just these 4 terms. This polynomial, 6x cubed plus x squared plus 7x plus 4. A common shortcut used to multiply by two binomials. So if you have two terms with two terms, so this is special for binomials, right? The product of two binomials is called the FOIL method. So it's FOIL because you're going to do, if you distribute, you're going to do the first term with the first term, then you're going to do the first term with the last term, and then you're going to distribute the b, and then b times d. But you're going to do it in that order. You're going to do the first terms, the outside terms, the inside terms, and the last. So me personally, I just like the distributed property, but a lot of people, you'll hear, most people will say FOIL. But again, it only works with 2 and 2, with binomial with binomial. So you're going to do the first terms, the outside terms, the inside terms, and then the last terms. So if I wanted to multiply, let's look at the next example. Use the FOIL method to find the product, 2x minus 18 times 3x plus 3. So we got two binomials. So I'm going to take the first terms, which is going to be so the first terms would be the 2x times the 3x. The outside terms would be the 2x times the 3. The inside terms would be the negative 8. Remember, you got to think this is plus negative 18 times 3. So negative 18 times 3x, sorry. And then the last term's negative 18 times the 3. So when you FOIL this, you do the 2x times 3x, so that's going to get us 6x squared. Then the outside terms, 2x times 3 is 6x. The inside terms, that would be negative 54x. Oops, negative 54x. And then the last terms would be negative 54. And we're going to combine like terms, so those two. So we get 6x squared. See, 6 minus 54, so 54 minus 6 is 48. Take the sign of the larger, so it'll be negative 48x minus 54. And that will be our final answer to simplify that, the product of those two binomials. So actually the FOIL method was the learning objective, the fourth one. And now there's one more multiplying one we're going to cover, which is the perfect square trinomials. So this is still within the FOIL. It's a special case for foiling, right? So when a binomial is squared, the result is the first term squared added to double the product of both terms and the last term squared. So let's kind of analyze this. If we were to FOIL x plus this part, x plus a, x plus a. So again, remember, it's just the distributive property. So x times x, your first, outside, that's a times x, inside, a times x, and then the last, a squared. And then these are like terms, so 1a plus 1a is 2a, 2a x plus a squared. So you got 2ax's. And you see that's where this formula. Squaring is something we do a lot in algebra, so it's worth our effort to, we can skip this step here, this step and this step, and just go straight to the answer. So if I have a perfect square binomial, or if I have a binomial squared, I'm going to square the first term. I'm going to do 2, because remember, I'm going to get 2 of them, and then just multiply the first and last terms together. So 2 times x times a, and we'll rearrange it as 2ax, alphabetical order, and then a squared. Okay, so if I want to do something like x plus 5 squared, it'd be x squared. I don't know what happened there. Okay. X squared plus 2 times x times 5, which is, normally I would just write 10, and then 5 squared. Okay, so normally I wouldn't write this down. I would say in my head 2 times 5 is 10 times the x, and then 5 squared is 25. Okay, and that would be the answer there. And this is what we call a perfect square trinomial, because you got 3 terms, and it's comes from squaring this binomial. So that's, again, this is called a perfect square trinomial. Okay, let's look at example 6, expanding the perfect square. So 3x minus 8 squared. So we're going to do 3x. Now think of the minus 8 as plus a negative 8 squared. So I'm going to take the first term squared. I'm going to do 2 times the first term. And again, normally I don't write this down. I just do it in my head and write the answer. You just got to practice that a little bit. And then the last one squared. So that's the shortcut. So the first term squared. Then I'm going to do 2 times the first term times the last term. And then the last term squared. Okay? So again, normally I wouldn't write this down. So 3x squared is 3x times 3x, so I got to square the 3, square the x, so it'll be 9x squared. And then I'm going to do the numbers here. 2 times 3 times negative 8 would be negative 48x, and then negative 8 times negative 8 is positive 64. And then that's my final answer there. And then with a little practice, you should be able to go from the question to the answer without showing any work and not thinking super hard. You should be able to do it in seconds. Okay, here's another special case for multiplying 2 binomials. This one we call a difference of squares. That's the answer here. So if I take a sum and a difference, so if I have a binomial is multiplied by a binomial with the same term separated by the opposite sign, the result is the square of the first term minus square of the last term. So let's look at this. Again, it's a special case of if I were to distribute or FOIL, since it's 2 terms. If I do the first terms, that's a squared. Outside terms, it'd be a times negative 1b, so that'd be negative 1ab. And then b times a for the inside terms. Oops, but then we want to write it alphabetical order. So that's ab. And then b times negative b is negative b squared. And you can see that these 2 terms cancel, and we're just left with what we call a difference of 2 squares. Difference being subtraction, and then the 2 squares, a squared, b squared. So we can create a shortcut and skip. We don't have to FOIL it. We're just going to square the first one, square the second one, and put a minus sign in the middle, and that's it. So if we look at example 7, okay, so we're going to multiply 9x plus 4, 9x minus 4. And you can see it fits this pattern of a difference of squares because they're the same 2 terms, just one's plus, one's minus, right? That's the key. So when we FOIL it, the middle terms are going to cancel out, and we're just going to end up with the 2 squares, the difference of 2 squares. So the shortcut then is you're just going to do the first term squared minus the second term squared. Okay, so we get 81x squared minus 16, and that's your final answer there. Okay, on to the last learning objective, perform operations with polynomials of several variables. Okay, so now we're going to look at example 8. multiply polynomials containing several variables. I copied this from the book just to kind of point out that basically polynomials can contain several variables. All the same rules apply, right? There's not really much different. So when I distribute this, I'm going to distribute the first term with each of them. So again, normally you wouldn't show this step. I'm just going to just to remind us of what's going on. So I'm distributing the x. So x times negative 2y plus x times 5. Now I'm going to distribute the 4. 4 times 3x plus 4 times negative 2y plus 4 times 5. And again, I'm emphasizing that this is plus a negative 2y. That's why it's in the parentheses. So normally, again, I wouldn't write that down. X times 3x. I'm going to do the numbers. 1 times 3 is 3. And then the exponents use exponent rules. X to the first times x to the first. That would be x squared. So for the variables, I mean. All right. Now the variables have to match to use the exponent rules. So, right, the bases have to match. So on this one, I do 1 times negative 2. That's negative 2. And I write just minus 2. I have an x, and there's no x here, so I just write down the x. And then I just have the y. So remember, this is x times negative 2 times y. It's just all multiplication, so I'm just going to rearrange it, put the numbers first. And then the variables, usually it's pretty standard, you put it in alphabetical order. So it'll be negative 2xy. That's all. So again, I'm going to do the numbers first. So there's a 1 times the 5. It's 5. And then the variables, alphabetical order, x. There's only x, so nothing else. 4 times 3 is 12. And then the x. Okay, and then now the next term, 4 times negative 2 is negative 8. And then the y. And then 20. 4 times 5 is 20. Now, are there any like terms? Now, descending order can be kind of confusing because we didn't really talk about, this. We consider this as a degree 2 term. So if there's a term that has more than one variable, you add the degrees of of each term. So this degree 1, 1 plus 1 is 2. So the term has a degree 2. So what does it mean to be descending order if you have more than one variable? Well, that, doesn't, you can basically just pick some way to kind of organize it. So if you just look at x squared, then all the x's, and then the y's, right? Or however. So for me, oh, wait a minute. Did I mess up here? This should have been a plus 5x. Okay. So look, I have these like terms, so I'm going to combine those, and I think that's it. So I'm going to have 3x squared minus 2xy. I'm going to combine these x's, 17x. And then I'm going to combine minus 8y plus 20. And we won't worry too much about what kind of order to put it, just as long as we have all the terms there. Okay, and that concludes the lesson for 1.4. So now you do the exercise set for your homework. Remember, it's the odds, or if I told you otherwise, do the homework and post it into Canvas. And see you next time.